students, welcome to the video lecture series on Chemical Engineering Thermodynamics 2. I am Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 3, which is a chemical reaction equilibria. So in this lecture, we are going to discuss about the various numerical based on equilibrium constant and mole fraction and rate of extent. So let's start with this numerical. So this is the most important numerical in point of view of exam. The water gas shift reaction that can be given by CO plus H2O gives CO2 plus H2. Is carried out under different set of conditions described below. First one, there will be the reactant consists of 1 mole of H2O vapor and 1 mole of CO. The temperature is 1100 Kelvin and pressure is 1 bar. Okay, so there will be a number of cases given in this example. So there will be 1, 2, 3, 4, 5, 6 cases given, and told that assume the given reaction at 100 and 1100 Kelvin and value of K is 1. So in the statement given that value of particular K, which is a 1. So let's here write given data K is equal to 1 for this temperature, and we have to calculate fraction of steam reacted in each case. So let's first write for case 1 what told in case 1. The reaction consists of 1 mole of H2O. So here I am going to write given data H2O 1 mole, then 1 mole of CO. So CO is equal to 1 mole. Temperature which given T is equal to 1100 Kelvin temperature and K is equal to 1 for each case. Okay. So and pressure is a 1 bar. P is equal to 1 bar. So we have to calculate the fraction of steam. So first, to find out the fraction of steam, we have, that can be given by Y of H2O. We have to find Y of H2O. How we can find Y of H2O? First, we have to make the equation for Y of H2O in term of the epsilon, or can say that rate extent. Then we have to find out the all the equation, or can say that equation for the all term, so that we can find the value of epsilon using that all equation. So that we can find the all the equation and for each compound, and then we have to find out the value of K. Okay, so value of K is already given. So which equation we are going to use? We have to use equation that can be given by Ky is equal to K upon K5 into P upon P naught whole raised to minus V. Okay, so this is the equation. For ideal state, this becomes 1. So can say that Ky is equal to K upon 1 into P upon P naught whole raised to minus V. Okay, so can say that Ky is equal to putting value of K. Value of K is a 1. So it becomes 1. Value of P. P is a 1 bar in case 1. So putting 1. P naught is the 1, then minus V which means total stoichiometric number. Stoichiometric number for CO is a minus 1, then for H2O it's minus 1, for CO it's a plus 1, and for H2 it's a plus 1, so it becomes 0. This is for CO, this is for H2O, this is for CO2, and this is for H2. Okay, so this is a stoichiometric number for particular component, and this is a total stoichiometric number for the reaction. So if I am going to put the 0 here, 0, anything above 0 power of 0, it becomes 1. 1 multiplied by 1 becomes 1. So ky is equal to 1. Now what is meaning of ky? Ky is equal to pi of yi whole raised to vi is equal to 1. Okay. So now I have to put the value of yi. So let's put the value of yi. What is meaning of capital Pi? Capital Pi as the meaning of sigma of xi, it means x1 plus x2 plus x3 and so on. Similarly, capital Pi becomes x1 into x2 into x3. So meaning of pi is the multiplication of each component. Okay. So how much component? There will be a 4 components. So first let's write for the CO. So y of CO, stoichiometric number of CO is a -1. So here I am going to write -1 here. Okay. Similarly, y of H2O. So y of H2O, stoichiometric number of H2O is a -1. So I am going to write here -1. Similarly, y of CO2, stoichiometric number for CO2 is a 1 because it's product, so it's a positive. Then y of H2, which is also 1. So both have 1, 1. So if I am going to rearrange this equation again, is equal to 1. Okay, this one here. So if I am going to rearrange this equation, it becomes y of CO2 into y of H2 upon y of CO into y of H2O is equal to 1. So can say that y of CO2 into y of H2 upon y of CO into y of H2O is equal to 1. So I have to find all the value of this. Let's suppose this is our equation number 1. Now let's find value of y of CO2. To find out y of CO2, first write generalized equation. Yi is equal to NiO, which is the initial mole of component, plus summation of Vi epsilon upon NO, which is a total initial mole, plus V into epsilon. Okay. So y of CO, that can be given by initial mole of this CO. So in this statement told that initial mole of CO is the 1 mole. So here I am write 1 plus summation of Vi epsilon. So here only one component CO. So this is Vi. Let's write stoichiometric number for CO is a -1. Here nothing right. So I am just considering there is nothing here. Okay. So here there is nothing. So it's considering 1, and stoichiometric number for reactant is a always negative. So it becomes -1 into epsilon. Okay. So it becomes 1 minus epsilon. Total number of moles in case 1 plus 1, so it becomes 2. So 2 plus total number of stoichiometric number for reaction is a 0, because -1 plus 1 plus 1 becomes 0. Okay. So it becomes 0. So 0 multiply with anything, it becomes 0. So this equation becomes y of CO is equal to 1 minus epsilon upon 2. Similarly, we can find this equation for all the term. To find out this equation, let's first find for the H2O. So for similarly, we can find for H2O 1 minus epsilon upon 2. Similarly for CO2, that can be given by epsilon by 2, because there will be no given mole of CO2. Okay. There is no mole of CO2 and H2. So I am considering this initial mole NO is a 0. So keep remember that if in statement the initial mole is not given of particular substance, then that initial mole is a 0. So we are considering the 0 mole for that particular component. Now let's make similarly for the H2, that can be given by epsilon by 2. Okay. Now Ky is equal to, this all equation is equal to 1. Okay. So Ky is equal to y of CO2, y of, here write y of CO2 into y of H2, y of H2 upon y of CO into y of H2O is equal to 1. So putting the value of this all equation, so y of CO2 is a epsilon by 2 into y of H2 is a epsilon by 2 upon y of CO 1 minus epsilon by 2 into y of H2O 1 minus epsilon by 2 is equal to 1. Okay, so simplifying this step, we will get epsilon square upon 4 upon 1 minus epsilon whole square upon 4. This 4 becomes cancelled, is equal to 1. Okay, so we will get epsilon square upon 1 minus epsilon square is equal to 1. Okay, so I am taking square root to both sides. So can say that square root of epsilon square upon 1 minus epsilon whole raised to square is equal to 1. So square root of 1, so it becomes epsilon upon 1 minus epsilon is equal to 1. Taking this to this side, so it becomes epsilon is equal to 1 minus epsilon. So taking this epsilon to this side, so it becomes epsilon plus epsilon is equal to 1. So can say that 2 epsilon is equal to 1. Okay. So epsilon is equal to 1 by 2. So epsilon is equal to 0.5. 1 by 2 is becomes 0.5. So this is the value of epsilon. Now putting this value of epsilon in H2O, we will get the mole fraction of steam. So what is the value of H2 is equal to equation of H2 is 1 minus epsilon upon 2. So y of H2O is equal to 1 minus 0.5 divided by 2. So y of H2O is equal to 0.5 divided by 2. So it becomes y of H2O is equal to 0.25. So this is a mole fraction of steam present in for the case 1. So here in statement told that calculate the fraction of steam reacted in each case. So I am finding the uh, our y of H2O is a 0.25 for this case number 1. Okay, so let's erase this all data so can easily understand. For case 1, answer is y of H2O is equal to 0.25. Now let find it for case 2. In case 2 told that data is the same as a 1, expect the pressure is a 10 bar. Okay, so here just pressure is a 10 bar, but as discussed in previous some lecture, we already discussed the effect of pressure on equilibrium conversion. So here we are just finding value of Ky, which is the equilibrium conversion. So what is effect of pressure on conversion? It's depend on stoichiometric number. As here we can see that Ky is equal to K upon K phi into P upon P naught whole raised to Vi. So it's depend on stoichiometric number. Now stoichiometric number for our reaction is a 0. Total stoichiometric number is a 0 because stoichiometric number for CO is a -1, H2O is a -1, for CO2 is 1 and for H2 is 1. So if we are going to sum of this all, we will get the 0. So here it becomes 0. Okay, so if here I am writing 10 or 100, that nothing matter because 100 power of 0 of 100 it will becomes 1, power of uh, power of 10 raised to 0 it becomes 1, 100 raised to 0 it becomes 1. Okay, so there will be no effect of pressure on this reaction. So for case 2 can say that y of H2O is 0.25. There will be no change in answer because in exam you have to write why the answer is not changed because pressure does not affect on this reaction, because due to that our stoichiometric number is a 0, so there will be no effect of pressure. Similarly, for the third case, we can find value of mole fraction that can be given by. For third case, all the data is the same as the one, expect that 2 mole of N2 is included in reactant. Okay, so here stoichiometric number is a 0, so there is no effect of inert material on epsilon. Okay, we discussed this case in various factor affecting on homogeneous gas phase reaction. So, on that we discuss effect of inert material. If the stoichiometric number is a 0, there will be no effect of inert material. So here N2 is providing as an inert material and there will be no effect. So can say that Y of H2O is becomes 0.25 because there will be no effect of inert material. So Y of H2O becomes 0.25 for this case. Now in fourth case told that the reaction are 2 mole of H2O and 1 mole of CO. Other condition are same as the one. Okay, so what here is going to change in case 1 told that 1 mole of H2O and 1 mole of CO, where in this case told that 2 mole of H2O and 1 mole of CO. So the all the equation are going to change. So we have to make equations again. So Y of CO here for the case 4. Okay, for case 4, Y of CO is equal to 1 upon epsilon divided by 3. Similarly, Y of CO2 that can be given by epsilon by 3. Y of H2O is equal to 2 epsilon by 3, and Y of H2 that can be given by epsilon by 3. Here total number of our component is changed. So here getting 3 in all the equation in case 4 compared to the case 1, and initial mole of H2O is a 2, so this equation is going to change. Here initial mole is a 1, so I am getting the 2 here, so there will be a difference compared to the case 1. Now using this equation I have to find the value of ky. So if I am going to put the value of all this term like this, we have to put using this equation ky is equal to, so let's write here ky is equal to Y of CO2 into Y of H2 upon Y of CO into Y of H2O is equal to 1. Okay, so putting the value of this all equation, Y of CO2 which is epsilon by 3, similarly Y of H2 is epsilon by 3 upon Y of CO 1 minus epsilon by 3 into 1 minus epsilon by 3 is equal to 1. So this will become cancel. Okay, so here I am getting epsilon square upon 1 minus epsilon whole raised to square is equal to 1. Okay, sorry, here there is a 2 epsilon. Sorry, so it's not becomes epsilon square. Here 2 minus epsilon is equal to 1. Now we have to simplify this equation. So if I am going to simplify this equation, we will get like this: epsilon square is equal to 1 minus epsilon into 2 minus epsilon. So epsilon square is equal to, we have to break this bracket, so it becomes 2 minus epsilon minus 2 epsilon and plus epsilon square. So epsilon square becomes cancel. So it becomes 2 epsilon minus 2 epsilon minus epsilon plus 2 is equal to 0. Okay. So minus 2 epsilon minus epsilon, it becomes minus 3 epsilon plus 2 is equal to 0. So if I am going to take this side, so it becomes 3 epsilon is equal to 2. So epsilon is equal to 2 by 3. So it becomes epsilon is equal to 2 by 3. Again, if we are going to calculate this term, we will get epsilon is equal to 0.667. So we have to just put the value of this 0.667 in this term. So we will get the value of y of H2O is equal to 2 minus 0.667 divided by 3. So we will get the answer of y of H2O. You have to do this calculation by own and you will get the answer of y of H2O. Okay. So this is for the case 4. Now let's discuss for the case 5. For case 5, the reactant are 1 mole of H2O and 2 mole of CO. So here just replacing the value of moles. In a previous term there will be a 2 mole H2O, where here is a 1 mole H2O. So again we have to calculate this term, and answer of expression will be interchanged, but there will be no change in final answer because we are going to put same as a H2O and CO. Both are a reactant. Okay, so there will be a no change in this answer of 0.667. We will get same answer for the epsilon. Now let's discuss about the case 6. In this case, the initial mixture consists 1 mole of H2O, 1 mole of CO and 1 mole of CO2. So we have to find the value for the again. So if we are going to find out and make the all equation, then if we are going to put the value in this equation, then we will get value epsilon 1 plus epsilon upon 1 minus epsilon whole square is equal to 1. And if we are going to simplify this term, we will get the value of epsilon, which is a 333. Okay, so we will get this type of answer for epsilon in case number 5, or sorry, case 6. So this is how we can find the value of epsilon and value of stream. We have to just put that value of epsilon in equation of the particular y of H2O. To make this, let's suppose again make the equation so it will be more clear. So here told that y of H2O is equal to 1 mole of H2O. So initial mole is a 1. So here I am going to write 1. Then stoichiometric number for the H2O is a minus. So it's minus epsilon upon total number of moles 1 plus 1 plus 1. It becomes 3. So 1 minus epsilon upon 3. And value of epsilon, here I get 1 minus epsilon upon 3. Value of epsilon is a 0.333. So I can write here 0.333 on 3. So it becomes value of y of H2O. So if we are going to calculate this term, you will get mole fraction of y of H2O or steam. So this is all about today's lecture. I am completing my lecture here. Thank you.